Hello everyone, once again welcome to our physics class. Hope you all are fine over there. Children, in the previous session we had discussed about motion in a straight line. We discussed about displacement, acceleration and velocity. And all those physical quantities were expressed in one dimension. But when it comes in the case of motion in two dimension or motion in three dimension, in order to describe all these physical quantities such as acceleration, velocity and displacement, we need to use a new quantity called vectors. What is a vector? How can we add, subtract or multiply a vector? What is the result of multiplication of vector by a number? So all these things should be discussed in detail. So let's discuss about all these concepts in this chapter, that means motion in a plane. So today we are going to start our new chapter, motion in a plane or motion in two dimension. Let's get started with today's session, my dear children. Children, as discussed in our introductory video, let's talk about vectors as well as scalars. In physics, we can classify quantities as scalars or vectors. Basically, the difference is that a direction is associated with a vector, but not with a scalar. A scalar quantity is a quantity with magnitude only. It is specified completely by a single number along with the proper unit. Examples are mass, temperature, time, etc. The distance between 2 points cannot be expressed in terms of the direction. So it's a scalar quantity. So mass, temperature, time, distance, all are scalar quantities. And the rules for combining these scalar quantities are the rules of ordinary algebra. They can be added, subtracted, multiplied and divided just as the ordinary numbers. For example, if the length and breadth of a rectangle are 1 meter and 0.5 meter respectively, then its perimeter is the sum of length of the four sides. That means it will be 2 into L plus B. Okay, so the length of each side is a scalar and the perimeter is also a scalar. And if the maximum and minimum temperatures on a particular day are 35 degrees Celsius and 24 degrees Celsius respectively, then the difference between the two temperatures is 11.4 degrees Celsius. Okay, so the scalars can be added, subtracted, multiplied or divided just like the ordinary numbers. That means they obey the rules of ordinary algebra. But at the same time, vectors are those quantities which has both magnitude and direction. And examples for vectors are velocity, displacement, acceleration, etc. So many other quantities are there. And they do not obey the rules of ordinary algebra. That means they cannot be added, subtracted, multiplied or divided just like ordinary numbers. So some special laws has to be applied in order to multiply, divide or add or subtract the vectors. And we will discuss more about such laws in this session itself. Next, let's discuss about position and displacement vectors. Before that, we must know how can we represent vectors. A vector is always represented by the symbol with an arrow mark on the top. And this arrow mark specifies the direction of the vector. Then also vector, in some books vector quantities are represented by bold letters like this. Okay, and the magnitude of the vector, magnitude of a vector quantity, suppose A is a vector quantity here, then magnitude of vector is denoted like this. This is the magnitude of vector. Magnitude of vector will be simply A, because magnitude of any quantity doesn't contain any sense of direction. So magnitude of vector will be simply the absolute value of that quantity. Okay. So now we can discuss about position and displacement vectors. Let's discuss it with the help of an example. Consider a Cartesian plane. O is the origin. Now consider a path like this. So this represents motion in a plane because we are considering the motion of an object in both x and y plane. So this is a motion in 2 dimensions. Now suppose initially the object is at this point. Let this point be P. Now after some time the object moves and reaches at this position, and let this position be P dash. Then what is the position vector? Position vector. In order to specify this position vector, we require origin. Okay, origin is chosen as a convenient point. So here P is the position of the object at a time t, and P dash is the position of the object at a time t dash. Okay, then just join from O to P. So this line OP is a straight line that joins O and P, and this OP is the position vector of the object at the time t. Okay, since it is a vector, we can represent the vector quantities by an arrow mark. So OP is the position vector. So position vector is always specified in terms of origin. In order to obtain position vector of any object at a particular time, just join that object position from the origin. Okay. Now what will be the position vector of P dash? In order to find out position vector of P dash, just join OP dash. So this line OP dash gives us the position vector of P dash at a time T dash. Now let OP is equal to R, and let OP dash is equal to R dash. Okay, then what is the displacement vector here? The displacement vector is the line joining from P to P dash. If we draw a line from P to P dash, the vector PP dash gives us the displacement vector. Okay, displacement vector. Again, P is the initial position, P dash is the final position. So P dash means the distance between initial and final position, which forms our displacement vector. Now here OP is the position vector. OP dash is also a position vector at the position P dash. How will you find out the magnitude of this vector? Length of this vector itself represents the magnitude of the vector. So here this is the length of vector OP dash. So this length itself will be the magnitude of vector OP dash. And here R dash, this is the length of vector OP dash. So this length itself will be the magnitude of vector position vector OP dash. Okay. Similarly, this is the displacement vector, and this is the length of displacement vector. So this length itself will be the magnitude of displacement vector PP dash. Okay. So it's very clear. Position vector is obtained by joining a line with that point from the origin. Okay. Now consider this graph. This is also a graph in the Cartesian plane. So P and Q are the initial and final position of an object. P is the initial position, Q is the final position. So an object at position P can reach the point Q through different paths. PQ is one path, PBQ is another path, PDQ is another path. So, which forms the displacement vector here? You know, displacement is the shortest distance between initial and the final position. And the shortest distance between any two points is always represented by a straight line. So here PQ is a straight line and PQ will be our displacement vector because it is the shortest difference or shortest distance between initial and final points. And this PBQ and PDQ will be the path length. We are more concerned about the path length here. So the magnitude of displacement vector can either be less or it can be equal to the path length or distance of an object between 2 points. Okay, so that's all about position and displacement vectors. Next, let's discuss about equality of vectors. So when do we say that two vectors are equal? Two vectors are said to be equal if they have same magnitude and same direction. Okay, so consider these two vectors, vector A and this is vector B. Whether A and B, are they equal? Yes. Why? Because they have same magnitude. Length of both the vectors are same. So if length are same, then their magnitude also will be same. So the magnitude of vector A and B is equal and their direction is also same. Both are pointing towards the same direction, towards right. So such vectors are equal vectors. Now consider this vectors. Let this vector be A, let this vector be B. Are they equal? If we consider the length of the vector or if we consider the magnitude, their magnitude is same. But what about their direction? Direction is not same. Both are pointing towards different direction. So these are unequal vectors. We can't consider these two vectors as equal. But at the same time, this set forms equal vectors because they have equal magnitudes and equal direction. Okay, and this portion of the vector is considered as the tail and this portion is considered as head of the vector. For any vector, the tip of the arrow is considered as the head and this end is considered as the tail of a vector. Okay. So two vectors are said to be equal only if they have same magnitude and same direction. Next, let's discuss about multiplication of vectors by real numbers. If we consider a vector like this, let this vector be A. Then what is this? What will be this vector? And when you look at the length of the vector, the second vector is double the length of first vector. So we can write the second vector is 2 times vector A. So multiplying a vector with a positive number gives a vector whose magnitude is changed by the factor with which it is multiplied. So here vector A is multiplied with a scalar number 2. So what will be the magnitude of this vector? Magnitude of this vector will be 2 times the magnitude of vector A. That means suppose initially if the magnitude of the vector A was 10, then now the magnitude of vector will be 2 into 10, that means 20. Okay, so if A is multiplied by 2, the resultant vector 2A will be in the same direction as A, but its magnitude will be twice as that of A. Now, what happens if we multiply a given vector A with a negative number? Say -1 or -1.5, like that. So consider a vector A and suppose this vector A is multiplied by -1. So what happens? When A is multiplied with -1, you will get A into -1 minus A vector. Minus A vector means magnitude is same but direction is different. So this will be minus A vector. Okay. Now suppose vector A is multiplied with minus 1.5. Minus 1.5. Then what will be the magnitude of minus 1.5 into A? This will be minus 1.5 into A. See, look at the magnitude and direction of minus 1.5A. Length of the vector is 1.5 times that of A, and also since a negative sign is present here, the direction is opposite to that of vector A. Okay, so whenever a vector is multiplied with a scalar number, its magnitude is increased by that number with which it is multiplied.